Hello, everyone. You are welcome to today's meeting. And in today's meeting, we are going to continue with the lesson on coordinate geometry 1. Okay, and we'll continue from where we left off in our previous meeting. In our previous meeting, remember, we looked at how to find the perpendicular distance from a point to a given line. Okay, and we equally looked at how to determine whether 3 or more points are collinear. Okay, so that is where we are going to continue from. The perpendicular, I think perpendicular distance to be precise. Okay, we cleared that, meaning we looked at all the possible examples. Okay, however, we couldn't look at what all the worked example questions under the collinear situation or concept. So we are going to continue from collinear, okay, concept or collinear points. Okay, so the worked example 2, okay, of the collinearity of points, that's what we can see on our screen. And if you look at these two questions, they are not directly, okay, the same, or I should say, you are not being asked to determine directly whether 3 points are collinear or not. Okay, if you look at it clearly, you can see that indirectly, okay, you are being asked to apply that principle of collinearity to find the value or possible value of A. So you've been given 3 points again, okay, and from the 3 points, okay, you are told that they are collinear. So here, you know these 3 points are collinear. And what are you supposed to do? You are supposed to find the possible values of A. And if you're able to do this, you use that as a guide to do what we have here because they are similar. Okay, so quickly, let's go and have a look at what the solution. So as usual, solution is what we write first. Questions are numbered because we equally want you to number your solution. So what do you do? Okay, write question number 2. Okay, we read question and see if you can underline salient parts. So here we know that the points are collinear. Okay, so collinear, we are supposed to find the values of A. Okay, so now you come to A. Sub question A. We extract what we are given. So given, and we have 3 points. Okay, so the first point with no name, okay, 1A with the coordinates. Okay, then the second point equally with no name. The coordinates are 4A and -1. Okay, and like I've said, you can also use a comma. And the last point equally without a name is what? 3, okay, 2. So this is what we have. Okay, now we are told that the points are collinear. And what did I say about collinear points? Under what condition? Okay, or what condition must points, 3 points for that matter, satisfy before you can say that they are collinear? My professors, are you there? I'm waiting.
They must be connected in a straight line.
Connected in a straight line. Yes, that is indirectly the definition. But if you want to make the determination, okay, you make use of a particular fact. I don't want to believe because I didn't give you assignment. Okay, you've forgotten. Okay, you didn't revise. Because that's the impression I'm getting. Because this is a straightforward answer. Okay, Amma. The gradient. Amma, I didn't get to you well. The gradient.
So the gradient of the first and second one, of the first and second point must be equal to the gradient of the second and third.
Okay, all right. Okay, so usually we'll say the gradient of the line joining the first and second point, okay, should be the same as this. So I basically said gradient of adjacent points. Remember, that's what I use. So that all that you are saying in brief, adjacent points, as simple as that. Okay, but take note. Okay, I equally said it is not necessary to use the adjacent point. Just take 2 pairs of points and work with it. Only that usually will say adjacent, but just take any 2 pairs and work with it. The pairs that are pretty, in your eyes, please take them and work with it. Okay, so take note of that. So very good. Okay, Amma. So in this case, this is what we are going to do. If you want to be more definite in terms of what we are going to do, okay, then remember, it will be better for us to label the points. So in this case, we could have started by writing let, because we know, okay, we are going to write maybe MAB is equal to MBC or whatever, so that when you are finding the gradients, at least you can be more definite. I don't know if is my point well made?
Yes.
Okay, so in this case, I will write let's, okay, the point A. Okay, take the coordinates of the first, okay, point. Then B, take the coordinates of the second point. And, okay, C, take the coordinates of the third point. Okay, so like I said, you can choose not to write given. You can equally start with let. Remember, we know this already. So at this point, we are going to, okay, so once the points are collinear, it means we are going to form 2 equations. I mean, an equation where we know the gradient, okay, joining of the line joining the first 2, which will be the AB, must be equal to gradient of the line joining what? B what? C, the adjacent point. However, this is what I am going to advise you again. Okay, if you look at what we have there, okay, I can work with A, B, then what? B what? C. I can also work with A, okay, C, and B what? C. The more reason why I'm advising you to always go for this point is that you can see that with this point, okay, it doesn't involve, okay, any letters. So I am going to choose my pairs in such a way that it will always involve maybe one, okay, involving a letter and one not involving a letter. So instead of going for A, B, and B, C, I will go for A, C, and B was C. It's my point well made. Because here we are liberty to work with any pair. Only that usually will say adjacent. Is that clear?
Yes.
Okay, so if you like, you can go and work with first 2, last 2. You end up getting the same results. Okay, only that, okay, the work here will be a little involving, especially with 2 unknowns. So this is what we are going to do. So I can say that, okay, so I'm going to get but I know that the gradient of AB must be equal to the gradient of what? So I said I'm using AC rather. So forgive me, let me go and I set out my plan, but I'm not going according to plan. Okay, so let's go and effect. So I will use AC must be equal to what? The gradient of what? BC. Is my point well made, my professors?
Yes.
Okay, so now this implies that, okay, MAC, so I'm using AC. So indirectly, C will be my terminal, initial will be this. So X1, Y1, S2, Y2. So gradient change in Y. So I'm going to get 2, okay, that's the Y2 minus Y1, which is minus A, over, okay, S2, 3 minus 1. So 3 minus 1. And that should be equal to MBC. So B is your initial, C is your terminal. So X1, Y1, okay, S2, Y2. So that one too will give me my numerator changing Y will be 2 minus 1. So it will be 2 plus 1. All correct? Okay, then the denominator will be 3 minus 4A. So 3 minus 4A. Okay, so at this point, we know this fraction, the denominator can be simplified. So I won't cross multiply onto numerator, denominator, any of them which needs simplification is simplified. So I will keep my numerator 2 minus A all over my denominator will give me 2. It's equal to Okay, my numerator 2 plus 1 will give me 3 all over my denominator, which is 3 minus what? 4a. Okay, so at this point, we can cross multiply. And I've told you, avoid using, okay, this indicating your cross multiplication lines. Okay, do that mentally. So this will give us the whole of this 1 times this. So I'm going to write 2 minus a, because it's a binomial, I put it in brackets. And this also is a binomial. I do same, okay, to it. And that must be equal to 2 times 3. That one, you know, is 6. So you can write it straight away rather than coming to write 2 times 3. Okay, so at this point, we need to expand the side. Okay, so it will be 2 times 3, which will give us 6. Okay, 2 times minus 4a, that will give us minus 8a. Minus a times 3, that will give us minus 3a. Okay, minus a times minus 4a, and that will give us plus 4a squared. Is my point well made?
Yes, please.
Okay, great. So at this point, we are more than good to go. Obviously, we can see a quadratic equation at hand. Okay, so let's see if you can simplify the side. But in the quadratic equation, you know everything must be on one side equated to 0. Fortunately for you, your leading term, which is the x squared term, is positive here. So we'll maintain, okay, that term here, which is 4, okay, a squared. Then your linear term will give us minus 11a. Okay, and what do? We need to move this one. So that will give us 6 minus 6. Initially, you would have known that they will cancel. So that will give you is equal to 0. Is my point well made?
Yes, please.
Okay, so at this point, you know, okay, that, okay, you can factor out what? A, because this is factorable. Remember, you are using a method of factorization to solve. So as for the numerical coefficients, I don't have any common numerical factor, so apart from 1. So I can only factor out A. If I factor out A, I'll be left with 4A. My professors, are you following?
Yes, please.
Nanayo, are you here? Nanayo, are you here? Okay, so now at this point,
Yes.
this is what we are going to do. Okay, so it will be 4a minus 11. Do you agree? It's equal to
Yes.
0. Okay, so now you can see product of two numbers giving you 0 means at least one of them is 0. So you come and set each of the factor to 0. So I will get a is equal to 0. Remember the connector is or. You cannot use a comma. You can't use and. I've told you comma and end, they have the same meaning. So it's really or as the connector. Then 4a minus 11 is also equal to 0. Here a is already solved for. It's this that you need to come and solve for your a. So you get 4a is equal to 11. You write it again before you divide. Okay, so you are going to get a to be equal to 11 on 4 here. So indirectly, I'm going to write this implies that my a is equal to what? 0. Okay, or, okay, I have 11 on what? On 4. But remember, I am going to conclude, so I will avoid concluding with this one in the, what do you call it? Improper fraction form, in its improper fraction. So I will draw my conclusion. Therefore, I was asked to find the values, but I won't write the values of no. Okay, just write the A is equal to state the values, 0, or you change this one, that will give us what? Okay, 2 whole number, 3 on 4. Am I right?
Yes, please.
Okay, so as simple as that. Okay, so you can see an application. Questions will not always be direct. Okay, as you saw. Okay, determine that these 3 points are, whether or not these 3 points are collinear. Straight away, then you go and determine, you know that. Okay, then you go and determine the information that will help you do that. So please take note. Okay, though you've been told that, okay, the adjacent, usually use adjacent. Okay, you can equally use any 2 pairs that you think are pretty to you. Okay, don't restrict yourself always to the adjacent. take two different pairs and work with them. That's all. Okay, any questions at this point before we move on? So on that note, you should be able to try this. Okay, you should be able to do this. Okay, it's basically here, all the points are not that pretty because all of them, each point involves a letter. Okay, each point involves a letter. So only that some of them, each coordinate contains, okay, I mean, a letter. So this one is not pretty at all. Okay, however, we can say that maybe this and this a little pretty because one of the coordinates does not contain, what do you call it, a letter. So I can work with this, okay, and this, okay, that is one. Then come and work on this and that, okay, or this and that. Any two pair will be okay. All right, so if my point is well made, then we are moving on to, okay, our next, okay, concept, okay, concurrent lines. Concurrent lines. So we are through with points. Okay, when it comes to collinearity, it deals with points. So collinear points. However, when it comes to concurrency, it deals with what lines. Okay, Adoma. Adoma.
Mr. Hackman, please, can you kindly move to the previous slide?
Today, I'm not going to accommodate
Yes,
that.
please.
So please.
Please, can you hear me?
I can hear. I said today, because of time, I'm not going to accommodate that. I'll send it. So if you can capture as early as possible. I wouldn't be going back like that on your demand.
Oh. Okay, I'm very sorry.
Okay, no, that's okay. All right, I know you are like that.
Please, I'm done.
Okay. Okay, so let's move on. Okay, so pardon me if I'm unable to do that, you know. Okay, the target. All right, so now what do we have? We are going to deal with concurrent lines. Okay, so quickly let me read. Concurrent lines are sets of 3 or more lines. So this time around, we are not dealing with 3 or more points. We are dealing with lines. So 3 or more lines meeting at a point. Meeting at a point. So here I have used 3 lines. 1 line, 2 line, 3. So if they meet at a point, okay, then we'll say that these 3 lines are concurrent. However, the point where they meet, okay, we have a special name for it, and that is point of concurrency. Okay, you know, okay, the point where 2 lines meet, what is the name given to the that point? Where 2 lines meet, our usual name. Point of intersection. So anytime you mention intersection, point of intersection, then we are looking at indirectly 2 lines. But immediately you move beyond 2 lines, okay, then you cannot use the intersection again. Okay, it will be point of what? Concurrence. But take note, okay, every point of concurrency has what? Point of intersection in it. So point of intersection will be a subset of point of concurrency. Afa.
Yes, please.
Okay, very good. Okay, yes, please.
But what you just said, the point of intersection will be the same for all the lines, right?
Yes.
Because
so
like they meet at the same point.
yes, they should all meet at the same point. So it means if I have this, okay. Okay, line 1, line 2, line 3. Sorry. Okay, these 3 lines, are they concurrent based on the explanation given?
No, please.
No, you can see that line 2 and line 3, they have a common point of intersection. Okay, but line here 1 is but for line 1. Okay, you would have gotten, so if this one passed through this point of intersection of L2 and L3, then it would have said that the lines are what concurrent. You get the point?
Okay, so yes, please. Please, another question.
Mm-hmm.
If they say we should find all these lines you've labeled, they say we should find the point of intersection of line 1 and line 2, we should just solve for line 1 and line 2. We shouldn't solve for like the point of concurrency before we
No,
go for the point.
I don't get you well. Anyway, let me move on a little. Maybe your question indirectly will be answered. If it's not answered, you can still come back with it.
Okay.
Okay. All right. So now we are saying that the point of intersection, a common point of intersection of 3 lines. Okay. Anytime you have 3 lines having a common point of intersection. Okay. I didn't want to use intersection here because maybe I've gone beyond 2 lines, but you can still use intersection because I've told you that concurrency has what? Intersection, okay, element in it. So when you realize that the 3 lines, they meet at a common point, okay, then it means the 3 lines are concurrent. So here, how do I determine what concurrency? Okay, and this is what you do. Remember, if you are dealing with collinear, okay, situation, you use adjacent what? The gradient of what? Adjacent points of the line joining the adjacent point. So with this one, you are not dealing with point, but you are dealing with lines. So it will be okay, the gradient, sorry, you won't use the gradient, you use the point of intersection, okay, of 2 adjacent, okay, lines. So if the point of intersection between 2 pairs of lines, okay, I should say adjacent pairs of lines are equal, the lines are concurrent. So in this case, you take, assuming maybe I call this L1, okay, L2, okay, L3. Oh, why am I using always the last one? I'll write C. L3. Okay, the adjacent lines will be L what? 1 and L2, then L2 and L3. Is that clear?
Please come again.
Okay, so remember when I was explaining adjacent, okay, in terms of whenever you talk of adjacent, there shouldn't be any, if I'm talking about adjacent points, I shouldn't have any other point between the point that I'm saying they are adjacent. So if I'm talking of adjacent lines, again, I should look at what? The lines that will not have any line between them. So if I take L1 and L2, you can see that there's no other line between them. So these 2 lines are adjacent. Okay, if I take L2 and L3, okay, no line between them. So they are adjacent. However, if I take L1 and L3, they are not adjacent because L2 is between them. Is it clear now?
Yes, please.
Okay, so work with adjacent what lines. However, again, it's not necessary to automatically or always work with, okay, what do you call it? Adjacent lines. Just take 2 different pairs of lines, whether they are adjacent or not. Okay, and find the point of intersection of each pair. If you realize that each pair, okay, gives you the same point of intersection, then you draw the conclusion that the lines are concurrent. Is my point well made?
Yes.
Very good. So I'm moving on to this one because of time. Okay, I don't want this to take our time. So later, maybe when you read it and you have issues, you can contact me, then I will explain a little, okay, further. Okay, we have special centroid, circumcenter, autocenter, and what have you. Okay, I won't talk much about that. So let's move on to our first worked example. Determine whether or not the given set of lines are concurrent. Okay, so now let's go and look at what the solution. So here, obviously, we can see that we've been given 3 lines. 1, 2, 3. So once you have more than a line, I mean more than 2 lines, then we've moved beyond point of intersection and to point of concurrency. Okay, so now solution is what you write. Major question number 1. Okay, minor question number A. Okay, I need to extract. So take note. I even told you that, or you've been told, anytime a question gives you more than 2 equations, you have to label. I should say more than 1 equation, you have to label. How much more? What do you call it? 3. So in this case, this is what we are. Each one you write, then you label. So given your first one, x minus y, okay, minus 1 is equal to 0. That becomes your first equation. Okay, so you label this as equation 1. Okay, then you come to, Okay, if you like, you can write comma and continue. I'm going to come down. So the second one will be x plus y. Okay, so plus 2y is instead. Okay, forgive me. So I wanted to see whether the other one too will have. So plus 2y. Okay, then minus 8 is equal to 0. That becomes your second equation. And your third equation will be, okay, x minus 5y, okay, plus 3 is equal to 0. So this becomes equation 3. Okay, all right. So at this point, okay, I am going to work with adjacent, okay, lines. So it means line 1 and line 2 will be adjacent. Line 2 and line 3 will be adjacent. However, if you take line 1 and 2, you can come and take line 1 and 3, just a different pair. It doesn't really matter whether they are adjacent or not. Okay, you will still draw, okay, that same conclusion. Okay, so I know if I want to determine, okay, that lines are concurrent, adjacent lines, the point of intersection must be equal. So it means I'm going to find the point of intersection of what? Equation 1 and equation 2 of these two lines. Is my point well made?
Yes,
And
please.
we are experts in finding the point of intersection. So let's go. In order to find the point of intersection, we know we have to solve simultaneously. That's one way. Or the other way, make y the subject in each of them, then come and equate. I've given you all the tools. However, I'm going to use the simultaneous equation. So if I look at 1 and 2, I can easily eliminate x. Coefficient here is 1, the coefficient here is 1. Because they have the same sign, okay, I have to subtract, okay, to eliminate. However, if I'm subtracting, I have to be careful because I always want to avoid negative, so that I will take one step out. So that step of dividing or multiplying by a negative. So in this case, if I look at 1 minus 2, I'm going to get minus y minus 2y. So that will give me negative. The other one will give me 2y minus y. So that will give me positive. So I'd rather do equation 2, okay, minus equation 1. Okay, I know I'm solving that simultaneously. Is my point well made?
Yes, please.
So that will give
Yeah.
me x, this x minus this x, that will go. Okay, that's your intention. You've eliminated x. Then 2y minus 2y, and that will give me 3y. Okay, then I will get minus 8 minus 1. So that will give you minus 8 plus 1. Is my point well made?
Yes, please.
So that will give us minus 7. And that should be equal to 0 minus 0, which is what we have there. Okay. Okay, so let's see what we are going to get. So if you continue, we are going to get here. We are going to make y the subject. Remember, we want to find the y coordinates of the point of intersection. So we are going to get 3y is equal to 7. You write it again before you divide. Y is not that pretty, but don't worry. Okay, it's still a coordinate. So you call this equation 4. Okay, then we will need 4 to find, okay, x. And remember, you are solving equation 1 and 2. So please, you cannot use this y on equation 3. You can only use this y to find x in equation 1 and 2. All correct?
Yes.
Okay, so we want to substitute this one into equation 1 instead. So 4, okay, into, okay, equation what? 1, comma. So that will give us what? X minus what? 7 on 3 minus 1 is equal to 0. So we are going to get x. Let's see if you can do this mentally. In terms of May's numbers, what would this give us? 2 whole number 1 on 3, am I right?
Yes.
So it will be minus 2 whole number 1 on 3. So you are going to get minus 4 whole number 1 on 3. All correct?
Yes.
Okay, and I want you to change that one to its corresponding, okay, improper fraction for me. Please, are you following? Otherwise, you know, you can use your calculator to do it. No issues at all. Especially this will be elective math. So if it's core math, we'll ask you to take the LCM and what have you. By elective math, you can use your calculator to do that. So I'm waiting. We said it is
10 over 3.
minus, come again.
It will be
Oh,
10 x equal to 10 over 3.
10 over 3. Okay, so are you sure it's minus 10 over 3? No, you are talking about x being equal to. Okay, so I will get x minus 10 over 3.
Yes.
So let me, before I come to the equal to. Okay, so let me do the writing. Okay, so that will all be on this. So x minus 10 over 3. Okay, it's equal to 0. So you get s to be equal to, okay, 10 over 3. So in this case, it means your point of intersection. So this implies that your first point of intersection will be, okay, 10, okay, 3, then 7, okay, 3 over 3. Okay, that is your point of intersection. So first point of intersection. Please, are you following? Okay, remember
Yes,
I told you
please.
in terms of points, you can choose not to change it to. Okay, you can even work with decimal, provided it is what? The exact decimal. However, if it's approximated, avoid. So if let's say this one was 3 on 2, which will give you 1.5, you can. Okay, so take note. Okay, you could have as well changed this one to, just for consistency's sake, change this one to mixed numbers. Okay, so now let's go and take the other one too. So I'm taking 2 and 3. So 2 and 3, I can still eliminate what? X. So if I want to eliminate, let me see. 2 minus this, so minus minus. So it will be equation 2 minus equation 3. That will serve, okay, the purpose that I'm looking for, which will be the positive, okay, term. So comma, so that will give me x minus s. That will go 2y minus 5y. So that will give me 7y. Okay, it's equal to, then I come to minus 8 minus 3, and that will give me minus 11. Am I right?
Yes.
Oh, did I write is equal to minus 11? It's not equal to, it will be minus. Why am I in a haste? Okay, anyway. Okay, so let me, yes, I'm coming. Go ahead, you can now ask your question.
Hello.
Hello. I'm listening.
Can you hear me?
Yeah, I can hear you now.
Please, why are you solving the other side?
Why am I solving the other 2?
Yeah.
Okay, you cannot use only 2 lines to determine. That's why we said we work with 2 different pairs. You get it? So
Yes,
you've done the
please.
first pair. We are going to look at the other pair. Remember, for collinearity too, did we use only 2 points? The gradient of 2 points? No. We have
No.
to go and pick another set of 2 points, another pair.
So, Mr. Hoffman, because we have 3 equations here and we are dealing in pairs, will we like is it only 2 pairs that we'll take, or we'll have to take 3 pairs?
No, I
Because we
said,
can do
okay, what 2 pairs can do? I mean, what 3 pairs can do, 2 pairs can equally do.
Okay.
Okay, so if maybe the first 2, okay, gave you a point of intersection and the last 2 gave you the same point of intersection, then it means automatically if you go and take another pair, it will give you the same point of intersection.
Okay. Okay, sir. Thank you.
Okay, you are welcome. Okay. Erase, is that you or?
It's Karen.
Okay, Karen, all right. Okay, Racy.
Mr. Hackman, please, why we got the x minus 10 on 3, please, when we did the 7 on 3 minus 1, please, did we get 4 whole number 1 on 3?
Let's see, this one gave us it will give us 2 whole number 1 on 3.
Okay.
Because 3 will go here too. So it will be negative 2 whole number 1 on 3 minus 1. So that will give us negative 3 whole number 1 on 3.
Okay, thank you very much.
You're welcome. Okay, this one you shouldn't be because your calculator can always help. Okay, are we all fine at least at this point? Hello, are we fine?
Yes.
Okay, so let's continue and find out. Aduma.
Mr. Akman, please, can you leave your points of intersection in a mixed fraction?
Please, can someone talk to Aduma for me? Aduma, did you just join?
Mixed fraction.
Oh, but remember I've addressed that issue. Please, have I addressed or have not?
Mr. Akman, my network is not really stable, so I'm not hearing all the questions and everything you are saying.
Okay, so I've told you when it comes to network instability, okay, I usually don't want this to draw us back. That's the more reason why it's recorded. So that when you get a recorded version, then you watch, then, okay, wherever the missing link is, you try to join. Is that okay? Especially today. So I've told you, okay, any point blank that unless otherwise stated, you are supposed to conclude with Ms. Names. Okay, but when it comes to points, I've told you, as for points, whether if you conclude with improper fraction, decimals, especially where the decimal is exact, no issues. I've already told you that. So you have that information already in your toolbox. Okay, take note of that. Okay, so now let's move on. I even said it today, just a few seconds ago. Okay, before you ask. So now, if you are going to solve for y, you get 7y is equal to 11. Okay, then we are going to write it again before. So you get, okay, y to be equal to 11, okay, on 7. We need y to find x. So you call this equation 5. Okay, so 5 into any of these two equations. So preferably, let me see, I'm looking for, so maybe I'll come and substitute, okay, here, because what y will multiply will be small. So I'm going to write 5, equation 5, into which equation? Equation 2. Okay, comma, and that will give you x, okay, my plus 2y, your y is 11 on 7. Okay, then minus 8 is equal to 0. So I'm going to get x, okay, plus 22 on 7 is minus 8 is equal to 0. So again, x, combine this using your calculator for me. I'm waiting. Hello, I'm waiting.
On 7.
Come again.
34 and 7. Negative 34 and 7.
Okay, so here will be negative 34 on 7. Okay, which is equal to 0. So yeah, even at this point, you could have drawn your conclusion, but we have to finish everything before. So you know your conclusion from that point. So x will be equal to what? 34, okay, on 7. So this implies that the point of intersection here will be, this time around, I'm going to change. Okay, so let's change each one to its corresponding Ms. numbers. I've told you in terms of points, okay, it will not be costly if you don't change. So let me, okay, leave it like that because the other one was also like that. Okay, then, okay, this will give us 34, okay, on 7. Okay, it's equal to point of intersection. Okay, so now let's see. Did we get the same point of intersection?
Mr. Akman,
Yes, please.
you exchange the coordinates.
Very good. Okay, anyway. So thank you very much. This can also happen to you as it's happened to you in, okay, some of the questions. So please take notes. Okay, this shouldn't happen at all. Okay, thank you for drawing my attention. Who was that? Okay, so that will give you 34 on 7. Okay, then what? 11. Okay, on 7. This wasn't intentional. It wasn't one of my usual tricks. Just to drum home my point. Okay, we have gone beyond this, so I didn't see the need to do that. Okay, so this is it. Okay, so once you didn't get the same point of intersection, so you know the obvious conclusion. So you write there for, okay, the lines are not, okay, concurrent. Afa.
Yes.
Okay,
Yes,
all right.
please.
Okay, so Amma.
Where the lines can produce 2 x coordinates or 2 y coordinates.
Come again.
Yeah, please. I said, would there be a situation where a line can produce 2 x or y coordinates?
A line. If you have a line
Yeah.
has a lot of s coordinates and a lot of y coordinates.
No, like the tangent and the seconds, what we did some time
Mm-hmm.
ago, actually we got 2 y coordinates, so we're able to determine which line is that. So I'm asking if we could also, if there will be a situation like that in these concurrent questions.
Okay, so here you are looking at the point of intersection. For the other one, you are looking at the point of intersection of a circle and a line. However, if I'm looking at the point of intersection of 2 lines, there is no way 2 lines can intersect, 2 straight lines can intersect at more than a point, true or false?
True.
True. Okay, so anytime you pick one pair of, okay, lines, and you find the point of intersection, you always get, provided they intersect, unless they don't intersect, but provided they intersect, they will only intersect at one point. So you only get s coordinate 1, y coordinate only 1 value. There is no way you get s coordinate 2 values and y coordinate correspondingly 2 values. No, if you are dealing with lines. However, remember the circle situation. I have a circle and I have a line. So the point of intersection can be none, it can be 1 where it is a tangent, and it can be 2. But for two lines, if I have 2 lines and they intersect, there is no way that they will intersect at more than a point. I don't know whether my point is well made. Your question is well answered.
It's well made.
Okay, all right, okay, great. Okay, so now let's do the B. I want to see if the B will end up giving us what the situation that we are looking for. Okay, so in any case, okay, let's see. Okay, if I can leave the B with you. Okay, at least I've made my point. Is that not it? So if you had the same point of intersection here, the first pair, the second pair, they gave out the same point of intersection, they would have concluded that the lines are concurrent. Is that clear?
Yes, please.
Okay, so if you understand, then I think it will not be necessary for us to do the B. You can try the B, okay, later. So quickly, let's go, okay, and look at our next set of questions. Okay, so my target is to finish this before, okay, our first break, water break. Okay, our water break. Okay, so question 2. Okay, so if the lines, so again, you've been given 3 lines, are concurrent, find the value of K. Okay, so look at what you have here. We need to find the value of K. So with this one, you are told that the lines are concurrent. The lines are concurrent. Okay, so this is what you need to do. Okay, and if you get the explanation here, you should be able to do this and therefore this. Okay, once this is in green, you know what I'm talking about. Okay, so quickly, let's go and look at the 2A. Okay, so 2A, and take note, I'm going to give you an advice. So here you know that the lines are concurrent. Okay, so meaning they will have a common point of intersection. Any pair that you take, the point of intersection, okay, of the lines will be the same. Is my point well made?
Yes.
Okay, so this is what we are going to do. Okay, don't stress yourself to work with. Maybe come and take the first two. Okay, solve for whatever. Come and take the last two, solve. Work with the equations always. Take this advice. Work with the equations not involving your unknown letter. So in this case, my equation 1. Okay, so let me extract, then maybe I can refer to that as equation 1. So given, as usual, okay, what do we have? 2x minus y minus 3 is equal to 0. I'll call this equation 1. Okay, then 5x, okay, plus ky, yes, please, or plus. Okay, sometimes the way you call me, I'll realize that there is something wrong somewhere. Okay, then minus 3 is equal to, so I've corrected it, right? Okay, and 3x, okay, minus y, okay, minus 2 is equal to 0. This becomes equation 3. Okay, so this is my point. Go and work with, because you know that the point of intersection of any pair that you take should be the same as the point of intersection of any extra pair or any other pair that you take. Okay, you are more than good to go. So if I want to take equation 1 and equation 2, can I easily find my point of intersection without involving k?
No.
No. The same for equation 2 and 3. So if you were supposed to go for the advice, or I mean the basic, okay, definition of concurrency, okay, we said adjacent. So if you had used the adjacent, okay, you would have found yourself in that trouble. Okay, so like I said, you can work with any pair that is friendly. So here, the friendliest, okay, pair will be equation 1 and equation 3. Do you agree?
Yes.
Very good. So now this is what we have. We go and work on 1 on 3 simultaneously. So let me see. I can easily eliminate y in equation 1 and 3. After listening to the equations are telling me I can eliminate what? Y. But I can eliminate by adding, because plus 1 minus 1. So I'll write equation 1 plus equation 3. All correct.
Yes.
So that will give me 2x plus 3x. That will give us 5x. Okay, Nanekia.
Mr. Akman, I thought you said we should find the point of intersection of only adjacent lines, or this
I've
one
said
you
a
can
lot.
choose any pair.
Any pair, that advice was given. Any pair at all you can choose. Only that conveniently will say that it's adjacent.
Yes.
So don't be too fixated on that particular definition. I've told you, just work with any 2 different pairs. That's all. It shouldn't necessarily be adjacent. Is it clear? When it comes to collinear, same for concurrent. Okay, so if my point is well made, then I can continue. Y will go. I will get this plus this will give me minus 5 is equal to 0. So I will get 5x is equal to 5. Write it again before dividing. So over 5 over 5. So x will be equal to 1. So please continue and find y for me. Okay, so if you go and find y, which I asked you to do, and you agree that you get y to be equal to this, so you can put x in any of the 2 equations that you solved. But here I went for this, because if I come and substitute it here, y is negative, so I have to move as an extra step. Okay, so that will be it. Y will be equal to what? 1. Take note. Okay, so in this situation, how would you proceed to find k? Any ideas? Let me see whether, you still, okay, show that indeed you are professors, how smart you are. Okay, Liz.
You put x and y, our numbers for x and y into the equation too.
Why?
And because we found k and y,
You
one
found
of x and y.
very good anyway, but it's your reason that, okay, I am still not buying because I've addressed this issue before. So I thought maybe you go straight to the point like, okay, you were taught. Okay, that's what you are supposed to do. You substitute. Okay, take note. Okay, this is it. Remember, okay, because we are saying that the point of intersection of this one, okay, should be the same as the point of intersection of any pair, meaning these three lines, okay, they are concurrent. It means if you take any pair and you solve and you get a point of intersection, that point of intersection will lie on the other line that you didn't solve, provided they are concurrent, or your line will pass through that point. So it takes us to the core math. Remember the core math, we did a situation, we handled a situation like that. Okay, if your point passes through this, your line passes through this, okay, find the value of, and I made this same, okay, point. Do you remember?
Yes, please.
Okay, so you know, once a point, okay, lies on the line, it means that point will satisfy the equation of the line. So just come and substitute the x and y into what equation 2. So in this case, I will label this because I'm going to carry out substitution for this equation 5. Then go and write just to make my presentation very clear and easy to follow. So I write equation 4 and, okay, 5, okay, into which equation? Into equation 2. Okay, so that gives me, okay, Karen.
Mr. Hackman, was wondering if, like the way when we solved the previous question, you concluded, like you wrote the points together, this is the point of intersection. Can you write it in, then you state that, substitute like.
Okay, no, you can see that here, unless maybe you want to write, since the points are, I mean, the lines are concurrent, I should say. Okay, but it's not necessary. Here you are told. The other one, we were making the determination.
Okay.
You get the difference. Here, you know
Mm.
that the lines are concurrent. So you know automatically they should have a common point of what? Intersection. They should meet at a common point.
Okay.
You get it? So we are just making use of that fact because we know that the point of intersection of these two, okay, that same point, this line will pass through. So it means the line will satisfy this equation.
Okay, sir.
Okay, very good. So that will give us y, which is 1. Okay, then we get minus 3 is equal to 0. So that gives us 5 plus k. Okay, minus 3 is equal to 0. So you get k, therefore k will be equal to, here to be this plus this, which will give us 2. You move. So k will be equal to minus 2. Is that clear?
Yes, please.
Okay, very good. So in the same way, find the value of p. Always you see that one pair will not involve the letter. So solve, because they are concurrent, solve these two. Okay, this will be the best pair to solve. Solve for the common point of, or for the point of intersection. Then you fix that point of the x and y into this, and you find your p. Is that clear? The same for this one. You solve the last two. Okay, this one you solve the first two. This one you solve the last two. What we did, we solved the first and the last. Afa.
Yes.
Okay, very good. Please, are we all fine, my professors? Okay, so if that's the case, then thank you very much. Okay, let's go and have our water break, 3 minutes. Okay, by 8:10, you should be back. Okay, so welcome back from the water break. Okay, so we are going to look at our next concept, which will be angle between two lines. Angle between two lines. You know, whenever two lines intersect, okay, an angle will be formed between them. So I'm looking at these two lines. Okay, we can have a special situation where the lines will meet at an angle of 90. Okay, or are not meeting at all. But if they are meeting, they can meet at a special angle, which is 90. That will be the perpendicular one. But I'm not talking about that situation. That's why I've qualified that. Okay, the acute angle theta. So, but however, take note, if this is theta, this is the acute angle. Anytime two lines meet and they are not meeting at an angle of 90, okay, two types of angle will be formed between them. One will be acute and one will be obtuse, true or false?
Yes.
Mr. Akman,
Should I come again?
yes.
Okay, I said when two lines intersect and they are not intersecting at a special angle 90, okay, two types of angles will be formed between these two lines. Okay, one will be acute angle and the other will be obtuse angle, true or false?
True.
True. Okay. However, the formula that you have here is for finding the acute angle. Okay, so you know, if you know the acute angle, don't you know the obtuse angle? Between them, you should know, is that not it? By subtracting the acute angle. So indirectly, if you know how to do this, if the question asks you to find the obtuse angle between the two lines, find the acute angle, then subtract it from what? 180, and that will give you the obtuse angle. Is my point well made? But I'm not here because of the obtuse angle. We are all here because of what? The acute angle. So the acute angle between two lines whose gradients are m sub 1 and m sub 2, okay, is given by tan theta is equal to, so there's a formula that you need to know. When you do trig, that's where, okay, tan will come in. When you do trig, this formula, okay, you will prove it there. Okay, but for now, you just need to know how to put the formula. That's all, and use the formula. As simple as that. Okay, so the formula says, okay, absolute value of m1 minus m sub 2. So m sub 1 minus m sub 2 all over 1 plus m sub 1 times m sub 2. So it means in order to show or determine or find the acute angle between two, okay, intersecting lines, we will rely on the gradients of the lines, because the formula here, okay, uses, okay, the gradient of the lines. Can you see that? Hello, can you see that? Because we said whose gradients are M1, M2. So the M1, M2 that we see here, our usual gradients. So take note, if the lines are parallel, we know, okay, then M1, okay, will be equal to what? M2. So if M1 is equal to M2, what will be your numerator? 0, is that not it? Okay, let me be very brief on that. Then if the lines are perpendicular, then M1 times M2 should give you -1. We know these two facts. Okay, but we are not looking at these two. We are looking at a situation where these two, none of them will be satisfied. So the lines will not be parallel and they will not be perpendicular, but they will intersect. Okay, and okay, because of time, I will not walk you through this. My main objective is for you to know how to put this formula and use. Okay, we are not going to show. Okay, so quickly, let's go and look at what we have here. So we are to find the acute angle between the following pairs of lines. The acute angle between the following pairs of lines. Okay, so you have A up to what? Up to D. So I will do the A, or we'll do the A together. If your understanding is not perfect, then we'll try the B just to perfect. But if your understanding is perfect with the A, then there is no need for us to do the B. Okay, then we move on to our next concept. Okay, so quickly, let's go and look at the solution. Okay, 1. Okay, A. What do we are supposed to find the acute angles. Okay, so in this case, 2 equations, so you have to extract the label each of them. So what do we have? 3x minus y minus 2 is equal to 0. So this becomes equation 1. And your second equation, which is x minus y is equal to minus 1. This becomes equation 2. Okay, what are we looking for? We are looking for the acute angle. Is that not it?
Yes, please.
Okay, so once you are looking for the acute angle, you know that the acute angle comes with a formula. Your acute angle comes with a formula. Okay, so remember I've told you any question that involves a formula, quote the formula and let the formula guide you. So in this case, I'm going to write, okay, but I know tan theta, where theta is your acute angle, will be equal to absolute value of what? Okay, M1 minus M2 all over 1 plus M1 times M sub 2, absolute value. Is that clear?
Yes.
Where theta is your acute angle, take notes. Okay, so now we need to go and find M1 and M2. And remember, M1 will be the gradient of maybe the first line. The M2 will be the gradient of the second line. So if I want to get the gradients of the first line, I have to go and work on the equation 1. So from the first linear equation, okay, if I want to get the gradient, I have to make y the subject. So in my mind, I'm moving y to the side. So y will be equal to, I've moved y here. These 2 will be here. So I will get 3x minus 2. So this implies that I know my m sub 1 will be equal to, after making y the subject and the 2 terms are explicit, I pick the gradient as the coefficient of the x. So that would be 3. All correct?
Yes.
Very good. Okay, so now what do? We come to that of what? The second gradient. So from the formula is telling us that we'll need the gradient. So that's why we are finding the gradient. So quote the formula and let the formula lead you, like I said. So from the second equation to, okay, we have to make y the subject before we can get the gradient. Okay, so y is negative, it has to move. So it will be equal to, however, this will come here. So I will get x plus 1. So in this case, the coefficient of x here will be 1. So it means my m sub 2 will be equal to what? Will be equal to 1. All correct?
Yes,
Okay, so at this point, then we can go and write. This implies that we are going to substitute. Okay, tan theta will be equal to absolute value of your numerator. We said M1 minus M2. M1 is 3 minus M2, which is 1, all over your denominator is 1 plus M1, which is 3 times M2, which is 1. Okay, absolute value of that. So tan theta will be equal to, okay, numerator will be 3 minus 1, which is 2, over denominator will give us 1 plus 3, which is 4. Is my point well made?
Yes.
Okay, which in effect will give us absolute value of what? Of 1 over 2. So absolute value of 1 over 2 will come out as what? 1 over 2, remember. Is that clear? Absolute value of A is A. Absolute value of minus A is A. All correct?
Yes.
Mr. Hackman,
Yes, please.
please, I have a question.
Okay, go ahead.
Please, does the 2 bars that are guarding the formula mean anything?
Yes, remember, anytime I've told you, we've worked with this,
Yes.
this notation, the absolute value.
Yes.
The absolute value will tell you that whatever you have here, the result shouldn't be negative. That's the length, okay, formula. I mean the length, what do you call symbol?
Yes.
So it's trying to tell you, so it's assuming maybe the result here, because we are going to deal with numbers, it's possible that the result here will be positive, negative, 0. I remember, okay, we've taken the 0 situation out. And we are saying that it shouldn't also be negative.
Okay.
So that's
So
the more
what
reason
is
why absolute. If it's negative, okay, then it means your angle will not be acute. Okay, when you do
okay?
trig, you appreciate, okay, acute angles are always in the first quadrant. So immediately you tan will be negative, okay, in other quadrants other than the first quadrant. So if
Okay,
tan of an
thank
angle is negative, then it's telling you that the angle is not in the first quadrant. It's the first quadrant, the angle will be acute. Any other quadrant, it will not be acute. Is it clear now?
please.
Okay, very good. So at this point, you are not looking for tan theta. You are looking for theta. Theta is your angle. Okay, so at this point, what do? I'll go and write this time. I think maybe, I don't know whether it's a new concept. So this implies that, okay, theta will be equal to, you go and take tan inverse, okay, of half. So here you need your calculator. Is this one new to you, the tan inverse?
Mr. Akman, this is new to me.
Okay, it's new to you. Don't worry. Anytime, okay, you have, this is it. Anytime you have sine, okay, of, sine, you did trig in JHS, is that not it? SOHCAHTOA, your usual SOHCAHTOA.
Yes, please.
So anytime you have cos of an angle, okay, tan of what? Of an angle, equal to a particular result. Okay, if you want to find the angle, it means you have to find the trig function here, its inverse of the value here. So if I want to find A, the angle A here, so let me use B and C. The angle A here will be equal to sine inverse of the results there. Because it will be over sine. 1 over sine, sort of as a sine inverse. Just as 1 over A. 1 over A is it not A inverse?
Yes.
So it will be
Will
that, as
will you
simple as that.
input that into
And
the
and it's
calculator?
just the calculator that will help you. So at this point, the work is for the calculator.
But how will you get the inverse
It's on the calculator.
calculator? When
It
I
is
press
the
it,
there
when
is
I
a
press
tan, there is a tan key. Okay, on top of the tan key is the tan inverse. So
yes.
press shift before you can access that key, the tan inverse key,
Okay.
because it's on top
I'll
of
be
it.
able to access it.
You've
Thank
seen
you.
it.
Yes, please.
Okay, I'll come for the money for using me as your manual. Okay, all right. Okay, so at this point, you need your calculator. So please use your calculator to give me this value, tan inverse of half. I'm waiting. Oh, by now you should be done. Those of you with a calculator, especially the one who was talking plenty.
86.56505118.
Is that what you are going to write?
Mr.
Did you
Akman
say
also
did you say 86?
26.
86.
So okay. All right. So let me go and do. Okay, forgive me. 26 instead. Okay, so 26 point
56.
Okay, obviously you cannot write everything. Okay, what did I say your first approximation should be?
4 decimal place.
4 dp. You have all the tools, so when you are supposed to use it, use it. So our first approximation should be what? 4 dp. So let's look at that, and it will be here
5651.
5651. I hope you consider the next digit.
Yes,
For
please.
okay, so 51. Then it is an angle, so don't forget the degrees. Is that okay?
Yes.
Okay,
Yes.
then don't forget also your approximation, which is 4 dp. Okay, and here there is no required approximation and there is no convenient approximation, so you can conclude with the 4 dp, only that you cannot conclude with theta. Okay, so you have to go and write, therefore you were not asked to find theta, you were asked to find the acute angle. So you can write 26 math followed by English 0.56, okay, 51 degrees. Okay, you shouldn't, okay, it's not necessary to write the 4 dp here because you've already stated that it's 4 dp. Okay, it's equal to the acute angle. Afar.
Yes, please.
You get it. So it's just the formula. Just the formula involves only the gradient. Okay, and in some books, okay, you won't see the absolute value. Okay, if the absolute value is not there, they will cure that by telling you that your M1 should be greater than your M2. So before you label this as your M1, this as your M2, okay, you have to find the two gradients. The bigger one is the one that you call M1. Okay, the smaller one automatically becomes M2. But okay, that is not necessary. Quote it with the absolute value. Whichever one that you find first, call it M1. The second equation, M2, that one you are not going to test whether which one is bigger than which one, because the negative would be taken care of by, okay, what you have here. Is my point well made? By the absolute value in the long run. Okay, all right. So that was just by the way. You will do the B. Should we do one more?
Yes,
Yes.
please.
Okay, great. No problem. Okay, so B. Okay, what are we giving? Two equations. Let's see. Okay, x plus 4y minus 12 is equal to 0. You call this as equation 1. Okay, then the second equation will be 2x minus y minus 6. Oops. Okay, is equal to 0. So this becomes equation 2. Okay, now what are we going to find? The acute angle. Okay, so you know it comes with a formula. So but okay, tan theta, meaning theta is your acute angle, will be equal to, Can you help me quote the formula?
M1
M sub 1 minus M sub 2, all over 1 plus
M
sub
sub 1 M sub 2, then absolute value. You close it. Okay, it's a cell. So you should have, okay, they're just like the bracket, only the bracket with a line. So you should have, immediately you open it, you close it. Okay, so that it doesn't come out. If it comes out, then it will come out with, if it's negative, reformed or transformed. Okay, so now, okay, we will need M1. The formula is telling us that we need M1, M2, and M gradients. So M1 will be the gradient of the first line. M2 will be the gradient of your second line. As simple as that. So how do I get the gradient of my first line? I was given the equation. So if I was given points, I will use the point to find the gradient. But I was given the line, its equation. So I would know how to find the gradient from equation of a line. So I will go and write from, okay, 1, I need to make y the subject. So y is positive here. I will maintain it. 4y will be equal to, move these two. Okay, this will be positive. So I will write that one first. If I move 12, this will be negative. So minus x. Okay, I haven't made y the subject yet. So I'm now going to divide, okay, by 4. Okay, and I can do that mentally, each of the terms. Okay, so this by 4 will give me y is equal to, this by 4 will give me 3. Minus this by 4 will give me 1 over 4. Okay, x. Is that clear? So this implies that my M sub 1, okay, is equal to minus 1 over 4. All correct?
Yes.
Okay,
Mr.
that,
Hoffman,
yes, my prof. Are you lost?
please, yes, can you come again? I don't understand what you just did here.
Yeah. Oh, we are just making, assuming I've given you this line, and I ask you to find the gradient of this line. You know the step, make y the subject, and find the coefficient of x as the gradient. This one, you know.
Yes.
All right. I think it's because you've not taken your breakfast. That's why. Okay, don't worry. Okay. All right. So if you move on, we are going to get from, we need to get our M2. So from, okay, the second equation. So please help me get the gradient in the second equation to convince me that you've understood. Okay, the one that, okay, said I should, you didn't get it.
Okay, so you have to make x a subject.
A.
Wait, you have to make y a
Break
subject.
fast.
Sorry.
Okay, why?
So you get Negative y is equal to,
You maintain the negative y here.
because you're making it the subject. That's
So
why.
you can equally move it here. That's what I did. You get it? So that you don't divide by negative. So sometimes you have to show, okay, Mr. Hackman in my presentation.
Okay. You get 2x minus 6 equal to y.
So can't you write that one as y is equal to 2x minus 6? It's the same thing. So though you are moving y to the side, you can still write y first, followed by all the terms here. That's what I did. You get it? Okay, so now, so this implies that m sub 2 will be equal to all right, it will be equal to 2, the gradient, the coefficient of x. Okay, so I think we are good. Okay, I don't know whether her network is giving her issues because I couldn't hear you. Okay, are you fine? So the gradient will be 2. Is that clear? Once you
Mr. Hackman.
Yes, please. Can you hear me?
Okay, yes. I can hear you.
Okay, so the gradient will be 2. At a point, we couldn't hear you, so we have continued. So immediately you make y the subject, and this side, remember I said they should be terms, not a single term. Okay, you have your gradient straight away just by picking your coefficient of x. So now we know m1, m2. So you can say that this implies that your tan theta, we will just go and substitute, will be equal to, okay, absolute value of m1, okay, is what? Is minus 1/4. Here we don't care whether that is greater than the other one or not. Okay, then minus m2, which is 2. Okay, all over 1, let me extend it, 1 plus, okay, minus 1/4. Okay, times what? 2. All correct?
Yes.
Okay, so if you continue, we are going to get this tan theta. I don't want to repeat it. Okay, it's equal to, it still means that it is there. So your numerator, let's work on it. That will give us what?
Negative 9/4.
Okay, because it will give us negative 2 whole number, 1/4. So we are going to get negative 9/4. All over, okay, this will give us 1. Okay, this 2 will go here too. So 1 minus half. Do you agree?
Yes.
Okay, so as we move on, tan theta will be equal to, let's see, the numerator will remain, okay, it's already a single fraction. Let's come and work on this one too. So absolute value of minus 9 on what? On 4. The denominator will be 1 minus half, which is half. Do you agree?
Yes.
Okay, so here we are going to get, we know, a fraction over a fraction, so it will be times. So I'm going to get this minus 9 on 4. Okay, times what? Okay, 2. All correct?
Yes.
Okay, so 2 will go here. So I'm going to get minus 9 on 2. Okay, but remember, the minus 9 on 2 will come outside as 9 on 2. All correct?
Yes.
Okay, so at this point, we are going to find theta because remember, this is tan theta, not theta. So I'll write, okay, this implies that my theta will be equal to tan inverse of this value. So tan inverse of the value 9 on 2. Okay, so I'm waiting again for your calculator value. Come again. Did I hear 57? 77. Okay.
Yes.
77.
0.4711.
0.4711.
1, 2.
1, 2.
1, 2. So please, when you are approximating, that's why we taught you how to approximate. Okay, when you were doing the real number system, because we know you need it. So make sure you do give us the right approximation. So remember, you are looking at an angle, so don't forget your degrees. And again, you have approximated. Never forget to indicate your approximation. Very important. So at this point, I draw my conclusion. Therefore, okay, 47.4712 degrees, okay, will be equal to my acute angle. Safa. Okay, very good. Okay, so on that note, okay, we'll move on to our next set of questions. So this one I will only explain. Okay, we won't handle it because of time. I think, let me see. Okay, the next concept, okay, less than 30 minutes. Wow. Okay, but you are doing well. You've helped me. Okay, so this is so find the possible values of t if the lines this and this intersect at 45 degrees. Okay, so it means here your theta is given, is that not it? You know the angle between them, so you quote the formula tan theta is equal to whatever. Okay, theta now you know, you are not finding theta, you know theta. So you go and substitute theta. Okay, then also you can find the M1 from here by making y the subject, which will involve t. Okay, your M2 from the second equation, which will not involve any letter. But because you have tan 45 will give you a value. Yes.
Line is breaking.
My line is breaking. Is it breaking at everybody's end?
No, yes.
No,
Okay, so please, if it's breaking at your end, then it means it's coming from you. So my point here is you write the formula will be tan theta is equal to whatever, but you know your theta, so it will rather be tan 45 degrees will be equal to your M1, which you will find minus your M2 all over 1 plus M1, M2. Okay, this. But your M1, like I said, okay, will be, if I make y the subject, M1 will be equal to what? T. Can you see that? So this will be T. Is that okay? Okay, then your M2, if you make y the subject, your M2 will be 3. Do you agree? Sorry, it will be minus 3. Because y will be equal to minus 3x minus 1. So this will be 3 minus 3. So it will be plus 3 here. If you substitute, you get it? Because it will be minus minus. Then it will be 1 plus, okay, t times 3. So 3t. So this is, if you substitute, that's what you are going to get. However, tan 45 will give you a value. Someone should give us tan 45. Calculator, use your calculator, not tan inverse or tan 45.
1.
1. So you have 1 is equal to t minus 3 over 1 plus 3t. Can't you solve this for t? You can, is that not it? So the questions will not always be straightforward. Amma.
Mr. Hackman, please, when we are extracting the information, the 45 degrees, should we write an acute angle equal to 45 degrees?
Yes.
Before we start the whole circle?
Yes, so you can write acute angle theta is equal to 45 degrees. So that when you substitute it, we'll know that, okay, there is a theta that is being represented by the 45.
Okay.
All right, great. All right, so quickly, let me also say this. Okay, to walk you through this. Okay, the lines, okay, this intersect at an angle of, at an angle whose tangent is what? 1/4. So it means this time round, you've been given the tangent of the angle. So what you have here is rather tan theta. You get it? The value here is tan theta. So he said the line, these two lines intersect at an angle whose tangent is, so the tangent of that angle is this. You get it? So if the angle is theta, tan theta you are told is 1/4. Is it clear from the information?
So, Mr. Akman,
So it means here it's going to be 1/4. Okay, is equal to your M1, which you can get from here, which is M. Okay, your M2, which you can get from here, which is -2. Then you go and substitute and solve for your M, as simple as that. So the formula still says tan theta is equal to whatever we have. M1 minus M2 over 1 plus M1, M2. Okay, but here the question said, see, the question didn't give you theta, you don't know theta. But the question said the tangent of the angle between them, and the tangent of the angle is tan theta. So it means though I don't know theta, I know the whole of tan theta, which is 1/4. So that is what you replace what you have here. And okay, M1, you get it from here, which will be M. M2 will be -2. You substitute, then you solve the resultant equation. Afa?
Yes.
Ama?
please, so this one too, how do we extract it?
So the same way, once you are given the equation, so given this equation 1, this equation 2, and again, okay, tan theta is equal to 1/4, as simple.
Okay.
You get to the other one, you were given, you were not given, you were looking for theta. So you have to go and find tan inverse. Okay, with this one, you were given theta. So you knew tan theta, 45. With this one, you were not given theta. Okay, but you know the whole of the tan theta. And that is what? 1/4. You get it?
Yes, please.
Okay, now please listen. The C. Prove that the triangle with vertices this is isosceles by finding its 3 interior angles. Okay, so it's like this is what you have. There's the picture. Okay, A, B, C. You need to find the interior angles here. And you are supposed to use the interior angles. Remember, if 2 of the angles are the same, then it means you are dealing with an isosceles triangle. Okay, if 3 of the angles are the same, equilateral, that's equiangular. Okay, none of the angles, then it becomes the scalene. So we can find the angles here by using that concept, the acute angle. So if you want to find the angle at B, please listen and listen attentively. If you want to find the angle at B, you have to look for the gradient of the line AB and the gradient of the line BC. And you know, once you know the point A and the point B, you know the gradient of the line AB. So in that case, let me call this maybe my M1. And you find the gradient of the line BC, that will give you your M2. Then go and use the tan theta. Theta is what you are looking for, the acute angle. And go and substitute, okay, into the formula and come and find theta. So that will give you the angle here. If you are looking at the angle at A, then you have to use the line here, this line and this line. So it will be the gradient of this line, okay, and the gradient of this line that you use. So you can take the gradient of this line as your M1 and come and take down the gradient of this one as your M2. Then you work with it. Or you can even call it M3 to avoid that conflict. Because if this is M2, you cannot label any other gradient as M2 again. So with this one, you use M1 minus M3 all over 1 plus M1 times M3. You are just using the gradients. So it doesn't really matter the name of the gradients that you give. The sub basically would distinguish between the gradient, that's all. Is my point well made?
Mr. Akman,
Yes, please.
when you find the acute angle of two of the lines.
Yes, don't go and find the third one using the formula. Okay, use the sum of the interior angles. You have to be smart.
Okay.
So subtract these 2 from, unless maybe you are not sure. Okay, that comes with the risks, because if one of them is wrong, you know that automatically it will be wrong. Okay, so you have to be very careful when you are finding the other 2, which we use to find the third one. Afa. Okay, all right. So this time around, you were not giving the equation of the line. You were giving the point forming the line. And with the point, can't you find the gradient? I don't always need the equation to find the gradient. I also need point to find the gradient. So the formula for the angle between two lines, you need the gradient. Whether the lines are given or the point forming the lines are given, you can get the gradient. That's all. You get the point?
Hello, Mr.
Hello? Are we fine? Can I move on? Okay, all right. So that will take us to, okay, our last word concept. Okay, please, is my line breaking?
No.
Okay, I've told you, if it's, may please disconnect and reconnect, it's coming from your end. Okay, so the last concept, which, okay, maybe time wouldn't, but I can still, if you're able to do the first one, I'm okay. With the vertices known, I'm very fine. Okay, so we are going to find the area of a triangle. The area of a triangle, the traditional formula that you know is what? Half base times height. Am I right?
Yes.
Okay, that's the traditional formula. When you know the base and you know the height. Okay, then the height will be any line drawn from the apex here, meeting this line at an angle of 90, what we also call the altitude. Okay, all right. So that's the traditional formula. However, if you are given the vertices of the triangle, okay, you don't necessarily have to go through this. There is a formula for finding the area which relies only on the vertices of the triangle. So if I have A with the vertices, I mean with the coordinate, I should say, x sub 1, y sub 1, B, okay, s sub 2, y sub 2, C, s sub 3, y sub 3, being the vertices of the triangle, then the area is given by this formula. The formula looks, okay, I mean, quite lengthy, okay, but I can easily, in fact, I will help you to easily quote it. Okay, once you know one term, okay, you know the other terms, sort of how to put it. Okay, so let's go and look at how best to use this formula. Okay, and this formula involves only the coordinates. Okay, all right. So if in the question, if the vertices are given, please use, okay, the formula that you were just given. Okay, or the concept that we are going to find the area of the triangle. Because if you want to use the other method, you have to find the base, you have to find the height. And since you are going to find the base and the height, any of them could be wrong. If any of them is wrong and you use it, you'll be wrong. However, this formula involves directly what you were given, okay, which will be the coordinates of all the 3 points. So in this case, if there is any issue, it will not come from you. If any point is wrong, okay, or if there's any issue and it will come from you after quoting the formula, then it will be an algebra issue. Okay, so quickly, let's go and look at the solution to, okay, Adama.
Mr. Hackman, please, in the name of God, can you please go back?
Okay, please, in the name of God, I said the rule, I can't go back. So just listen and get the understanding. You think you can corner me with God? I won't mind you. All right. Okay. Okay, so we have some few minutes. Let's get it. You always get the video to watch, Adama. Is that okay? Okay, let's cover. All right, because today possibly will be our last meeting. So solution, question A. Anytime the figure is mentioned, remember, in the question, it means you have to draw. That's why the triangle is here. So I'm extracting the information in a picture form, and that will give me A. I always put my apex here, or the vertex, so 3, 0. Okay, B. Okay, will be 10, -2. Okay, then C with a coordinate 12, okay, 3. That's what we have. Okay, now, this is the information that you have here that you've extracted. So it's like, if you like, you can write given here as well, because this is what you were given. Okay, what you were given in terms of a picture. Okay, the sketch. And I've told you, don't use your free hand, don't draw in ink. You know all the basic rules. So now we know that this, for me to find the area involves a formula. So I'll write, but my area, okay, will be equal to, so if you like, you can write area A, okay, will be equal to, I'm quoting the formula, there is half in it. Always, for all the formulas that you get and the area of a triangle, half will come. And it will be absolute value of, take notes, okay, it will be x into y minus y. That's what you write, first of all. You repeat the same, okay, you repeat it, two more times. So we are going to get plus, you write the same thing. Why? Because we are going to get 3 of that, because you have 3 coordinates for each of the x and y. So you get, sorry, that right, y, x, I'm repeating this, copy and paste, y minus y, then plus the last one. Okay, I will come down because it won't go there. Otherwise, maybe I will push it. Let me write it here and later push it, or let me come down. Okay, so I'll write it here. So it will be x into, again, y minus y. Okay, and this is how you fill the sub. Okay, always. So the first one is x sub 1. The second one of the second x will give you s sub 2. The third x will give you s sub 3. Please, are you listening? I'm helping you quote the formula easily. So it will be x into the difference of the y's if you look at the formula. So when you get the first one, you repeat that 3 times, because you need to get s how many times? 3 times, because your x here, s coordinate, you have 3 of them. So this is how you move, how you get the sub. Okay, you know, you are looking at, okay, s 3 times, so you have 1, 2, 3. X will be this. Y will also have sub 3 times, 1, 2, 3. So this is all that you do. From 1, okay, this is what you have, is 1, 2, 3. So from 1, what do you go to? Which sub do you go to? So move according to the numbers. Okay, as simple as that. So from 1, you go to 2. So it will be 1, 2, 3. From 2, you go to what? I want you to see the pattern. 3. From 3, what do you go to? Do you go to 4? So you come back to 1. Is that not it?
Yes, please.
Okay, so it will be 1. From 3, you come back to 1, then 2. Okay, as simple as that. So let's go back to the formula and see. Okay, if that is what you notice from the formula. So it will be 1, 2, 3. If you come here, 1, 2, 3. Okay, 2, 3, 1. 3, 1, 2. As simple as that. You get it?
Yes.
Okay, so that's how easily I am able to recall. Okay, so if that is useful, you adapt. Okay, so now at this point, this is what you do. This becomes x sub 1, y sub 1, x sub 2, okay, y sub 2, x sub 3, y sub 3. So just go and substitute. So that will be equal to half of absolute value of, and again, absolute value, because area is a physical quantity, cannot give you negative. So what is x sub 1? X sub 1 is minus 3. Okay, into what is y sub 2? Y sub 2 is negative 2. I hope you are with me.
Yes.
Minus what is y sub 3? Y sub 3 is 3. Okay, then plus what is s sub 2? S sub 2 is what? 10. Into what is your y sub 3? Y sub 3 is 3. Minus what is y sub 1? Y sub 1 is 0. Hello, are you following? Okay, then s sub 3 is 12. So just go and look for your subs and substitute. That's all. Y sub 1 is 0. Minus y sub 2. Y sub 2 is here, and that is minus 2. So it will be minus 2. So plus 2. All correct.
Yes.
Hello, is my point well made? If you've not been given the opportunity to talk, please mute. Okay, so at this point, we are going to get half out, absolute value again. This will give you, come and work with what you have in bracket first. So minus 3, then minus 2 minus, okay, 3 will give us into minus 5. Then plus, this is 10. Come and work with what you have. So 3 minus 0 will give you 3. Then plus 12 into 0 plus 2 will give you 2. Then you close your absolute value. So it will still give us half, okay, of what? Okay, this will give you 15. Okay, plus this gives us what? 30. Then plus this gives us what? 24. Am I right?
Yes, please.
Okay,
Yes,
so that is going to give us 1/2 into absolute value. Let's combine this. So this will give us what? 45. Okay, so 45 plus this will give us 69. Am I right?
Yes, please.
Okay, so 69. Oh, sorry, absolute value. So the 69 will come out as what? As positive. So I'm going to continue here, assuming that's my next page. So I'm going to get, okay, I will move the line here very soon. Okay, so that will be equal to, I'm going to get half of, it will come out, 69 will still come out as 69. So it will be 69/2. Okay, so I want it mixed numbers. So therefore, my area, okay, is equal to, what will be the mixed number? 69/2.
34 whole number and on 2.
Okay, 1/2. Okay, so please take note, it is area. An area must always have what? A unit, and the unit will be what? Squared. So it will be unit, okay, squared. Is that clear? If you know the exact unit, okay, then you write, okay, that unit there. As simple as that. Is my point well made? So it's all about quoting the formula, substituting your x sub 1. So your first point will always take x sub 1, y sub 1. Your second point will take s sub 2, y sub 2. Your third point will take s sub 3, y sub 3. So just come and pick them and substitute. Make sure you substitute the right values. Then after that, the rest will just be algebra. And your conclusion, don't forget to attach unit squared. That's it. Is my point well made? Okay, unfortunately, we couldn't look at the second, but that's okay. The second one, when you know the size, okay, you couldn't look at that. So if you know the size, quickly, let me speak to it. If you know the size, okay, then it's given by this formula. Okay, once you know this formula, the A and BC will be the three sides that are known. Okay, however, the S will be what we call the semi-perimeter. So the S will be, you add all the three, okay, sides, that is forming the perimeter of the triangle, then you divide by 2. So that's why it is called semi-perimeter. Okay, so you know how to find the S, which will be, so first of all, you need to find your S, because these 3 will be given, A, B, C will be given. So what you need to find after quoting the formula will just be your S. Then come and substitute your S, A, B, and C into the formula, and you simplify and you attach unit squared. Is my point well made? It's just a formula. Know how to quote the formula and how to use it. Okay, so Amma.
Mr. Ackman, please, what's the meaning of semi-perimeter?
Oh, I just explained though. The perimeter is, how do you find the perimeter of this triangle? If the sides are A, B, and C, by summing all the sides around, is that not it? The distance around.
Yes, please.
And anytime we are talking about semi means half.
Yes, please.
Okay, so you divide by 2. So that's why it's called semi-perimeter. Okay, all right. Okay, so that will be it. Okay, and okay, thank you very much for a wonderful lesson. God bless us all.